Hi, in this lecture, we're going to be looking at scenario analysis. What is that? Well, in the previous lecture, we looked at two independent projects. You were choosing, and we're looking at some waste management options and whether we're going to do one in-house or out-house. They're basically um, two separate events or two separate projects. But what if we're looking at one project and we're looking at various scenarios, hence the name, pretty easy name, for that project, different outcomes and probabilities listed for each one of those outcomes. Maybe things might go great, things might not go so great. Maybe the economy is on fire and things will go super, or maybe the economy will tank. And what are those probabilities that we assign? And it could be anything. It could be the economy, it could be whatever that we're assigning to those probabilities of different scenarios happening with a single event or I guess a single project. So, and that kind of makes sense. Let's say you want to build a hospital, and kind of a grand event, a grand project, but you want to build, let's say, a hospital. And then there's various things that could happen to the outcome of that hospital or that endeavor. Everything from a good economy to a bad economy. For example, I've seen hospitals built in areas or smaller hospitals, little 100-bed or less hospitals built in areas where they anticipated the urban push was going to move out that way, that eventually they would be surrounded by these major urban centers that appeared to be growing in that direction. What if that didn't happen? They planned it. So all of a sudden you've got a nice little hospital in the middle of a cornfield and there's no community around that. That can happen. But there's a probability, an event of that happening. So we're going to look at scenario analysis, look at present values and expected values for a scenario analysis. And yes, we're going to bring back, I know, our old friend. You love standard deviation, but hopefully you found it not as intimidating as it sounds from the previous modules where we did standard deviation, and we're going to bring that back. So we're going to look at that. So let's go to the Magic Blackboard, as always, to run through an example that will hopefully illustrate and help your understanding of this topic.
As with all of our examples, I'd like you to try to follow along with pencil and paper. Have a calculator handy. I think that's how you get the most value out of doing this, seeing how I'm running the math on these different problems. Now, here we're going to be looking at scenario analysis, and I think it's a great tool, relatively easy to do, and something that you may need to use in the future as a healthcare manager, as a supervisor, if you're ever involved with a particular event or project or piece of equipment, and you want to look at various different outcomes. Again, this could be anything, like it could be building an outpatient facility, it could be a freestanding emergency department, which are kind of popular right now, or it could be something relatively smaller, like a piece of equipment. So in this case, I have used, just as an example, I have used an ultrasound machine, a portable ultrasound machine. Those are the little tiny ones that look like laptops, easy to bring in and out of a patient's room. You basically can carry these under your arm. But like any technology, they tend to go obsolete pretty quick because it's, in essence, a glorified computer with some probes on it. So they have a relatively limited lifespan before they're pretty much no good anymore. So, or you have the next best generation coming up behind and you got to buy that one as well. So, but again, this could be any scenario that you want to look at. But again, I've just made these numbers up, so they're not, don't trust them as exactly how much these portable ultrasound machines cost, but I think that's pretty close. But what we have here, we've got the various years. We've got years 1 through 3 on here, with year 0, that's the initial purchase of this machine, and then the estimated revenues coming in years 1, 2, and 3. Okay? Remember that when you see the parentheses, that's a fancy kind of accounting finance way to have a negative. So that's the cash outflow. Also on here, and this is where we're really looking at calling it a scenarios, are the various scenarios that are going to happen. And those are indicated by these probabilities that you see up here, which I'm marking with the little X's that I'm trying to write an X on here. You have probabilities of different outcomes that may impact the purchase of this machine. So let's say it's patient volume in this case. There's a probability that a 30% probability that you're going to have a given number of scans. And that's what this means right there. Remember, probability, 0.30 is 30%. So there's a 30% chance you're going to have a given number of scans that would generate this revenue, and this revenue. Then there's a 50% chance right here, okay, that you're going to, hey, it's going to be even better. We're going to have a lot more patient volume and patient scans, and we're going to generate this kind of revenue. And so on with a 20% case where you're making a lot more money here. So again, different scenarios that we're going to be looking at. Attaching the probabilities to these various scenarios, again, is that thing that we've talked about throughout the course, that fuzzy zone. How is that determined? What are those probabilities? Yeah, that's kind of that area where it's maybe not too clear cut. But you should make an attempt at it at your best, using the data, using environmental surveys on what you think may happen. So you can prepare for kind of the worst case, most probable case, and best case scenarios. And to protect your organization as well from a worst case scenario that it doesn't completely cause a disaster. And that's pretty much what we have here with the probability of worst case scenario, with these lower revenues at 30%. The most probable case is 50%, and the best 50%, and the best case is that 20%, where you're making significantly more revenues. Also in this little scenario, the cash flow on year 3 is a little bit more than the other cash flows. Okay, so look at this year 3 cash flow right in here, and look at that across the board. They are a little bit more, I'm assuming there's a little bit of salvage value included in this machine. You trade it in, they give you, I don't know, let's say in this case about $5,000 trade-in value for the machine that originally cost you $20,000 3 years ago. Yeah, sounds about right. Okay, so let's walk through this using this grid. We're going to be referring back to the grid here. Let's walk through one of the first kind of approaches to scenario analysis. And what we're going to be looking at as the projects, okay, we're looking at the project's expected, okay, net present value. And we're going to run through that calculation. You might hear the term used, base case. Okay, that's an S, base case. Don't let that throw you. It's not best case, it's base case. For scenario analysis, again, don't let it cause you any concerns. And we'll walk through this as we go through here and using as far as the referencing to base case. But what we're going to do here is look again at the project's expected NPV. How do we do that? Well, the first thing that we want to do is and these will be all skills that are very familiar to you. Everything that we're doing today is something we have already done before. So this the process will not be too much of a surprise. How we apply it might be a little bit different. All right, so the first thing that we want to do is we want to find the expected value, and we're going to make a new column. I think it's probably the best way to approach that. So we're going to make a new column, and I'll just call it expected, value. Okay, and for each one of these years, okay, so each year we're going to go across and find out that expected value. Now, there is a nice little trick with year 0, and because of year 0, I'm going to use my trick, and then I'm going to show you, we will walk through years 1, 2, and 3. But because year 0, notice how the dollar amounts are exactly the same, right? It's a $20,000 cash out. because the probability is the same, because the dollar amount is the same, even though it has different probabilities, because all of the probabilities, if you add all the probabilities up in your scenario, here's a question, thought question time, add up all the probabilities in your scenario, what should they equal? Remember, we talked about this. All probabilities of any given scenario should equal 1. And they do in this case. So and 1 meaning 100% probability. Because I know the dollar amounts are all the same and my probability equals 1, I know that the expected value for year 0 is, well, it's obviously, there's no other expectation other than $20,000. Remember, K means 1,000. So we're going to list that down as 20, and that's a parentheses. Okay. All right, let's work on the next ones. And I'm going to use the bottom half of our magic blackboard here to do that. And if you remember, to do that, all we do is the probability times that particular value assigned to that year. So with 30%, year 1, we're looking at the 5,000. Okay? Then sticking with year 1, remember we're doing year 1, so this is year 1, okay? And we're going to go through each one of the years. Now we're going to move on. Probability, next one. Okay, plus what is that? 0.5, right? 50% times 10,000. Plus, I think you're following me here, right? 20% times 15,000. Let's continue with our math. That's going to equal something, but I'm just going to help clean this up a little bit. So 0.3 times, sorry guys, that's actually another 0 right there, times 5,000 is going to equal, let me check my calculator here. Yep, looks like that's 1,500 plus 0.5 times 10,000. That equals 5,000 plus 0.2 times 15. See where I'm getting that, right? And that equals, checking calculator, 3,000. Great. We're almost there. We're going to add these all up together. Let's see, 5, 6, 7, 8, 9. That's going to equal 9,500. There we go. So we've just calculated the expected value year 1. You probably can see where I'm going with this. Okay, so I'm going to write that in there. Now, let's do, I'm not going to do year 2. Do you want to know why? It's the same numbers. Easy math, right? It's 5,000, it's 5,000, it's 10,000, it's 15,000, it's same probability. So I've got that figured out for me. So I'm going to write that down here. Remember, I'm doing a column here. Okay, this is kind of a new column that we're solving. I'll just bring it back out to here. I think that's the best way to do that, at least for me, is to do a column. Kind of, again, calculating the expected value for each year. Now let's erase this and my eraser is not working. There we go. And it's not working. Okay. So let's try one more time. And not working. Okay. Well, let's scratch that out here, but I will let's write the new one down. I think you got the pattern. We're going to do year 3 now. So that was basically year 1, 2, year 3. Still got our same probability, but now we've got multiplied times 10,000 plus 50%. Oh, we've gone up to 15,000 plus 0.2 times 20K, 20,000. Wow, that's a great deal right there. Let's do some, let's get that simplified a little bit more. Let's see, 0.3 then times 10,000, that's going to equal 3,000. Terrible 3 there. Plus, let's do the math, 7,500. By the way, if you ever see me make a mistake, let me know, and might get some bonus points for it, because I'm kind of making this up as I go here. So we've got, add these up all together, and that's a 7. So 7, 8, 9, 10, 11, 1150, there we go. Okay, so we've got 14,500. 14,000. That's a 14. $500. All right. Now, we're almost there. So what we want to do, remember what we were looking at in the very beginning before we started all this, is the project's expected net present value. So we haven't done this part yet. I think you know how we're going to do that, right? We're going to bring back our old website calculator that I really like on net present value, and we're going to be plugging in these cash flows. That's all we've got here to get that project, I'll call it P net present value. Okay? All right, well, let's take a look at how we're going to plug those in. All right, I've brought up our net present value calculator from our calculatedstuff.com/financial NPV calculator. You guys should know this. We've already talked about this website. I'm not going to give you the URL again. Let me shrink this down just a little bit if I can. Let's see if we can get this to shrink here. And then so we can see these numbers here, hopefully side by side, getting high tech on you. And let's see if we can enter in this information. Okay, our initial investment, we know what that is. That's that $20,000. Okay, our discount rate, what would that be? That would be our corporate cost of capital. Now, we haven't talked about that, so let's plug in a corporate cost of capital. Again, that'll be something that will be probably given to you, but let's assume in this case, let's pick an interest rate 1. We'll do our corp cost, and we'll use, let's use 10% because it's nice and easy, okay? So our corporate cost of capital that we'll be using for this example will be 10%. All right, let's go back to our website, and we'll enter that cost of capital in there, and we're going to say 10%. Cash flow in year 1. Remember, using that expected cash flow, because it's expected net present value for the project, and that was 9,500. Hopefully you see where I'm getting that from. Year 2, that was the same. That was 9,500. Year 3, that was the 14,500. And we're not using years 3 and 4, so I'll delete those. Love this calculator. All right, and let's see here. Make sure we've got everything that we need listed. Looks good. I think we can hit calculate. All right, and we get our net present value, as you see listed here, and that's going to equal $7,381. Well, I'll say 82. Okay, so we'll just round it. All right, so there you go. So you've just calculated the project's net present value based on scenario analysis. So that's a good, kind of a good step in understanding on how we're doing this. Let's take a look at a couple of different ways to strip this problem apart. The next thing we're going to look at are what are the project's most likely, worst case, and best case NPVs. Okay? Now, let me see what I can do real quickly here. See if I can shrink our calculator down here. And we'll just move this off to the side. And see if I can bring that down even smaller. Wow, isn't that great? Okay, so we've already talked about what that might mean when I talked about a few moments ago that we have our worst case right up here. Okay, worst case. We have our what I would call probably the most likely or most probable, so most likely. And it's by the percentages, right? So what's most likely? 50%, that's most likely. What's the worst case? Well, you look at the dollar amount, the revenue flows. Looks pretty bad. What's the best case? So the best case is right over here, okay, best case, where you're you're making a lot more money, but that's only a 20% chance of that happening. All right, so let's tear this apart. Let's make another little row here. So we're going to be looking at the net present value, but now not for the expected value of the project, but for each probability. Okay, so I think you can see where we're going with this one. And so we're not going to be so concerned about the probability of each event, but we're going to look at each one of these events, the probability of maybe the economy not being so good, not doing enough scans, the probability here about 50% of the economy being not bad and doing some more scans, and then the kind of the best case scenario of maybe a lot of patient volume, a lot of good economy, and a lot of scans that you're doing with that portable ultrasound machine. All right, so let's bring back our friend over here. Let's see if this works. We'll try to bring it up here. We do have some overlapping. Let me take care of some of the graphic issues on this real quick. Okay, I think I've taken care of those crazy lines that were kind of showing up on there. We're going to use our NPV calculator, and we're simply going to be plugging in our cash flows. So we already know our corporate cost of capital, which we have listed. Okay, we've already got the initial investment, which is $20,000. Now we're just going to plug in the cash flows for the worst case scenario. And let me shrink that back down a bit. And let's see, year one for that first probability was $5,000. Year two, $5,000. And year three was $10,000. And we're simply going to hit calculate. And there we go. And we'll go ahead and write that down. And that's going to be a negative $3,809. Let's do the next column. Try to move my calculator over here. Maybe kind of hard to see this one, guys. Yeah, I think we can probably scooch it right down here. Might be kind of small, but if you're on YouTube, just use the open that window all the way up. Okay, let's go ahead and plug those in. We've got the $20,000 initial investment already set. Remember, we're doing the 50% probability now, kind of the most likely event. So hold on here, I'm trying to get that window to activate. I think we got it here. All right, so in year 1, it was 10,000, so let's get rid of that, 5,000. Okay. And then let's see here. We're going to do another 10,000. Again, hope you're following along with me here. And then we'll do 15,000. That included potentially some salvage value in there. Okay, so let's see what we've got. Got our 20, our cost of capital of 10. See where I'm getting these cash flows from? 10, 10, 15, 10, 10, 15. See them? Okay, good. Let's go ahead and hit calculate. And there we go. So we now have 8,000. $625. Okay, and that's a positive. All right, so let's move our calculator off back to the side here and just rewrote what we've got here. Net present value on probability, the 30% probability. There is the 50%. And then if let's do the 20, I'll go ahead and do that one for you, but I think you know how to work through that, and then I'll plug that number in here. All right, so off camera, I just ran those cash flows, and we have 21,059. All right, these are all dollars, of course. So this is all dollars. So that's net present value for each one of the scenarios. So that's all there is to it. So you now have, for this particular question, what is the net present value for the most likely? Okay, boom. What is the net present value for the worst case? Well, actually a negative net present value. That's not good. And what is the net present value for the best case scenario? Okay, not too bad. All right, let's look at our next question on how to kind of tear apart scenario analysis. And this will be easy. You're going to love this one. What is the project's expected net present value on the basis of the scenario analysis? Wait a second, Chris. That sounds like what we just did here with the project's net present value based on that base case. Remember, not best, but base case. And we came up with this. Well, for scenario analysis, the net present value for the project, okay, net present value for the project is the same. So if you see a question like that, you go through the same, you could go use the same procedures. I'll show you how it works, just so you know that it works both the same way. But you can kind of save yourself the calculation, if you will, from doing that by just plugging in or using the work that you've already done. But let me walk you through it, just so you can see that the math works, and I hope it does now that I've talked it up. So let me get our blackboard set here and walk through this one. Okay, to save time, I've set the problem up for you, just going to show you that it's going to equal the same. But what I've done here is I've taken the probabilities, okay, times the net present value, which you already calculated. You calculated all of these right down here. We did those. So the 30% times the net present value of that particular scenario, which was a loss, which was at 3,809, kind of rounding a few dollars here, et cetera, okay? Then simplifying that, just doing the math on that, add those up all together, and let's see what we get. Looks like we are getting, again, I've introduced a little rounding error into this whole thing. And then that, and then minus. Perfect. Well, within $1. Pretty close. Okay, so I do all that and I get 7, 3, 8, 1. Again, I've rounded as I've gone along. So as you can see here, it's the same. You could do it this way if you want. Again, net present value, the project's net present value under scenario analysis, what again is incorporating all the various scenarios that you've just done. You know, same. Okay, so now you know how to approach, should you get that question, you know how to approach that. All right, kind of saving the best for last, and we'll have to probably start off with a new board here, but it will be relatively easy. But we're going to do what is the project's, okay, the project, the whole thing, you know, when we talk about the project, what is the whole project's standard deviation? All right, so if you want to take a break, this might be a time to take a pause. Then we're going to come back and work through that. Now, hopefully you've written down all that information from the first slide, because we're going to be bringing some of that back in to this standard deviation calculation. But if you remember from standard deviation before, the first thing that we want to calculate is the variance, okay? So, and it's actually, this isn't too bad. It's gonna yield you some pretty big numbers. You just got to keep track of the numbers. But just set up the variance. Think of it like this. I would again like to write it in English so it conceptually sinks in a little bit better for me and hopefully for you too. The variance is basically the probability of the whatever, you know, these individual 3 different probabilities we've talked about for this ultrasound machine, okay, times that return, okay, again, that kind of expected return for that individual probability, okay, minus the expected return for the whole project, okay, which we've already calculated. We've already calculated this. We've already calculated this. We know that. Nothing here to calculate. We just need to plug those in. And then we're going to add the next probability onto that, times, you know, et cetera, plus, you know, and then in this case we have 3 different probabilities, okay? And then that is going to equal our variance. So what does that look like? Let's do our first one. We have that 30% chance. And remember what the expected return for that 30% chance was? That was a negative 3,809. And then we're going to subtract that times the project's expected net present value, which was that 7,381. And this is where you're going to get big numbers. Squared. Nope, I forgot to do that. Squared. Did you catch me on that one? Yeah, squared. And remember that this, just a little aside here, this part right here, okay, the project's expected net present value, when you look at that bell curve, that's this right here, okay? And then we're looking for standard deviation. We're kind of looking at the tightness, you know, of these returns. Is it really tight? Is it really wide? Okay? All right, so we've set up our first one. Then we're going to be adding that. You can write this in all one straight line if you want. I think that's a little hard to do. The next probability was that most likely, right? and that was 8,625 if I remember correctly. And that's going to be minus 7381 squared plus 0.2, and the expected value for the best case scenario, not the most probable, was around 21,000 and $0.59 minus 7381 squared is going to equal variance. All right, let's do the math on this. Now there is one change. I'll stop right here before we get into some really big numbers. You were using percentages before. You were using a percent, 12, 13, whatever, to find that. This could be apples, it could be percentage points, it could be patients, it could be whatever units you're dealing with. In this particular case, we're dealing with the units of dollars. Okay, so that's kind of makes it any easier than the last one, which we were dealing with when we were doing standard deviation. It was from percentages of a return. This one we're looking at the dollars, okay? But it could be anything that you're calculating standard deviation on, whatever units you wish to choose. Widgets, percentage points, dollars, patient head count, whatever. Okay, all right, so let's go ahead and crunch the numbers. So be careful, make sure that when you do math, you're doing, doing within the brackets first, okay? And the weird one with this is that there is a negative. So a negative minus a number, minus this is basically a positive number. You might remember if there's a negative minus a negative, it turns into a positive. But this is normal, so don't worry about that. In most cases, it's always going to be normal. So you're going to subtract these two together. That's actually going to come up with, well, we'll run the first one for you real quick. So get your calculators out. And remember, you're going to probably have to turn, if you have a iOS device, you have to turn it landscape mode to get all the nice little features, especially the square root and to the power of 2, the cube root, or the n to the squared. It can only visible on the calculator when you turn it into landscape mode. But let's see here, 3,809 negative minus 7,381 equals $11,190. That's a negative. I'm going to square that. Again, your calculator should have a little function on there that looks like that. You're going to hit that button, and you're going to get a really big number. You're going to get, I'll just write this down so you guys can follow along. You're going to get 125,216,100. And remember, I didn't do this yet. And that's going to be multiplied times 0.3. Okay? So you're going to do the multiplication on that. Take it down. It'll take it down a little bit smaller, but it's still going to be a really big number. And that's going to equal 37,564,830. And you're going to go through that process for each one of these. And what you'll end up getting is 37,564,830 plus, trying to do the math real quickly here, 773,000, that's 768, plus 30, another 37,417,000, 536. See what I was talking about? Not too difficult math, but really, really, really big numbers. You're going to add these all together, and you should get around 75 million, 76 million right in there. So 75,756,134. So there is your variance. Okay? So here we go. And then what do we do? Remember, we need to get our standard deviation. Oops, that's a D, or our sigma. And all we need to do is to square root that bad boy. So, because you probably just have it entered in your calculator last, but I don't. Let's put that back in there. 34, and hit the square root button. And that equals a much more manageable number, so that knows I'm kind of making sense. $8,703 is your standard deviation. Okay, that's your standalone risk, that's your standard deviation, that's your sigma. There you go. Remember, the square root button on your calculator will look something like this, or it may look like this. In my case, it's got the little 2 in there to say that it's a square and not a cube root, which don't even worry about that. But just hit that button and then you get your answer, and kind of makes sense, so that you now know what the standard deviation is for the entire scenario analysis. Okay, not too hard, pretty easy. You just end up having some really, really long numbers, and just kind of be careful. I guess the only thing is the attention to detail with the numbers, and hopefully I haven't made a mistake here. But be careful with the large numbers. But at the end, it usually crunches down to a much more reasonable number. That's sort of my feeling. When I know I've got it correct, it's something that looks kind of what I was somewhat expecting. So, all right, so there you go on standard deviation. Let's run through one more thing and then we'll be done. All right, well, let's take a look at this by one final working of this problem, doing a risk adjustment on it. It'll be easy. We're going to bring back our calculator right down here that we've got, and I'm going to show you a couple different ways, or talk about a couple different ways you can do this, but we're ultimately going to do the easy way, is my suggestion. And it's also going to bring it full circle for you, because when we talked about risk adjustment, we talked about that in our first lecture. And that's really adjusting for a project that, for whatever reasons, you deem that it has increased risk. Okay? And remember that we were also dealing with, in our last lecture, cash outflows, and that we wanted to lower that corporate cost of capital by whatever that risk adjustment rate is. That'll be given to you, usually decided, probably the CFO of the company has decided or calculated somehow what an appropriate risk adjustment rate would be. That'll be given to you. In this case, we are deeming this project more risky, okay? But we are dealing with cash inflows, kind of the normal situation, or the kind of the fun part. And with this one, we want to, this is kind of key here, guys, we want to make sure that we increase that interest rate, that corporate cost of capital, whatever, that discount rate, all the same thing. We want to increase it. So in the first situation that we had with lecture 1, we had an inverse relationship. With this one, it is not inverse. They're going to be, working in tandem together. So if you remember, our corporate cost of capital when we started this whole thing was 10%. Okay? And now our CFO has determined that we have a plus or minus risk adjustment rate of 2%. The question is, well, what do I use? Do I use 8 or do I use 12? Well, I've told you right here, you use the 12. Okay? If this was a cash outflow, we'd use the 8. Let's say you forgot that. Do both. It's not that hard. Literally takes 5 seconds. You could do both. And if the one thing that you remember kind of that principle of conservatism. Or think of it as the Debbie Downer. What is the worst thing? What is the thing that makes it look the worst. Again, that protects your organization from excessive harm, you know? So, you know, you would calculate these, and you would find out that an 8% is going to give you a better net present value. Well, that shouldn't make any sense because it's actually the situation has gotten worse. The 12% should, if we're all looking good here, should actually give you a lower NPV. So you could always do both, and then you'd realize, oh, this one can't be right, and you would toss that one out and you'd keep the 12. Or you could try just to remember this, okay? And that should help you. Either way, though, you'll get it solved. Well, let's go ahead and plug into our calculator and see what we get for a risk-adjusted project net present value. Okay, so we're risk adjusting this guy right here. Now, as I said, there's a couple ways you could do this. You could approach this from going with each one of these, okay, and risk adjusting it with our new rate, okay. You're going to come up with a new answer right down here, and you'd add them up. But you're going to be doing this 1, 2, 3 times. If we just stick to the base case, or right here, the expected values that we've calculated, we're only going to do it once. So let's just do it once. You can do them both ways and see what you get. You'll get the same thing. But I'm going to show you just the easier method. All right, let's see if we can get my web page to work here. And we'll plug in the values. Our initial investment, again, we calculated that at $20,000. Okay, we've got our new interest rate, or corporate cost of capital, risk adjusted. Okay, we got that. We've got our cash flows. And that is 9,500. Another 9,500. Remember, those are the expected values for each one of those years. Year 3, we got a little bit of salvage in there. It went up to 14,500. Oops. There we go. And we can delete off these years. We don't need them. All right. So let's say we got everything in there. And do you see where I'm getting these from? Getting them right up in here, okay? And we're just plugging them in. Let's hit calculate. And let's check what I did wrong. I think I got an extra 0 in there somewhere. Oh yeah, sure do. So let's adjust that to 20,000. There we go. Let's hit calculate now. There, that looks better, doesn't it? Okay, so we've got a project net present value of $6,376 and some coins. Does that make sense? Yes, it does, because when we used our corporate cost of capital at 10%, remember we got that 7,381? Now we've used a higher cost of capital, so our net present value is not looking as attractive. And that's what you'd want to do. Well, let's just see. Let's go ahead and calculate. Let's say we didn't know what to do. We had to use both numbers, the 8 and the 12. What would happen? Easy to do. Calculate. Now see what you get. You get 8,451. Would that make sense? The project all of a sudden got more risky, yet it looks more attractive? No. So you'd say, nah, I used the wrong one. This one, more risky, look bad. So that's what you want to do. Still might do it, but you would at least have a hopefully more accurate representation of what would affect your decision on whether you want to go forward with the project. So is the project still financially attractive? Yeah, I'd say it is, right? We still have a net present value, positive. I think it's still attractive. So it did go down by about $1,000, but not too bad. When you considered, we did use our risk adjustment rate of 12%. All right, so there you go. We have calculated quite a bit. Let's just summarize. We found the project's expected net present value, kind of using what we call base case. That was right up in here. We did this thing right up in here. Okay, we got that one. We found the project's net present value for, this is the tricky words, there's base case and best case. So don't try to get those confused. But we found the net present value for each of these kind of worst case situation, the most likely situation, and the best case or best probable, however you want to term that situation. We also found the project's net present value on the basis of scenario analysis. Remember, that was when we calculated going this way, just with these numbers here, calculating the net present value for each year, using that, again, same answer. So that was kind of an easy one for us. And then we did our friend, I know you love this, we did our standard deviation. We figured that out, or standard deviation or sigma. We found that. Remember, the numbers are going to be big, but just kind of work through it, you'll be fine. And remember, those their units are units, whether they're percentages, patients, dollars, whatever, when you're doing standard deviation. And now we've done, bringing it full circle, we've done a risk adjustment on our scenario analysis. So there you go. Hope you find scenario analysis a pretty useful tool. It can do a lot, pretty easy to do. You don't need any sophisticated computer software to do this, and I think it provides a very rational way to approach a particular situation. As I've said in so many of these lectures, the real question, the real, art of the science of finance are determining the probabilities. What are the probabilities? What are the probabilities that you invest $20 million in a freestanding emergency department that it's going to work? That's where it's going to be the difficult, and that is where you make the big bucks. All right, hope you found this lecture enjoyable on scenario analysis.